Hello, everybody. Thank you. Welcome to this new session. I hope you're having a great time and sessions already so far this morning. This one is presented by Dr. Ludger, who is a chemist at Siemens Energy. And the very crucial topic he will be covering now is turbine oil, the requirements, the monitoring, and improvement measures. So, Ludger, we're really looking forward to hearing what you have to say about this. Thank you.
Okay, thank you, Guillaume, for the introduction. Ladies and gentlemen, I welcome you to my presentation, Turbine Oil Requirements, Monitoring and Improvement Measures. The table of contents is as followed. I make a short introduction of my company. I speak about our turbine oil specification, which we use for years, about monitoring of turbine oil, and about improvement measures. Afterwards, we have maybe some questions that I can answer then. We see ourselves as an integrated energy technology company, providing products and solutions along the entire energy value chain. I work in the gas service business area, where most of the rotating equipment is located. Industrial turbines and compressors are in the transformation of industry business area, which is also one of the 4 business areas of Siemens Energy. Gas Services has about 25,000 employees worldwide and 150 years history. We have more than 7,400 machines running, all heavy-duty gas turbines, aeroderivative gas turbines, and industrial gas turbines, and of course steam turbines. We are located. I'm located in Mülheim, which is one of the big plants of Siemens Energy, which produces generators and steam turbines. Our large gas turbines are produced in Berlin, our second big plant in Germany. And we have also a plant for medium-sized gas turbines in Finspång, Sweden, and also one big plant in Charlotte in the US. They mainly produce the generators for the machines, but do also service business. About a third of the employees are in Germany, a quarter in the United States, 10% in Sweden, and the other in the other countries worldwide. Our core business is turbines, large gas turbines, small gas turbines, medium and aeros, but we have also decarbonization in our portfolio, like H2 co-firing, but we have also electrolyzers to make hydrogen, and we have also solutions for energy duration, energy storage, and industrial heat pumps. And we have a lot of customers in different areas of the industry. Here's our gas turbine portfolio to get an impression what types we all produce. We start with a small 2 megawatt machine, and we end with a nearly 600 megawatt machine, which is our new HL class as a 50 hertz machine. Here you see the rotor of this huge machine. And for the industrial applications, we have the SGT 800 built in Finspång in Sweden, which is the biggest industrial gas turbine for energy production. And here we have the steam turbine portfolio. We start with 25 megawatts up to 250 megawatts. It's industrial applications. And for utilities, we have steam turbines up to 1900 megawatt. One was built for a nuclear power plant in Finland with 1900 megawatts. These are really huge machines. And if you think about lubrication, one of these low pressure rotors, the turbo set has 3, is more than 380 tons, one of these rotors, to get an impression what we have to lubricate with our oil. These are the three main products for gas turbines. The F-class in the market since more than 20 years now, of more than 50 million operating hours. The SGT 800 for decentralized industrial energy production, and now the F-class, the HL class with a high efficiency, and with 2 Guinness World Records, like you can read here, for the most powerful simple cycle gas turbine and for the highest ramp rate. And the high ramp rate is really necessary for the decarbonization. With the increase of renewables, you need such a good fast start and high ramp rate capability. This is built, the first test machine is built in Charlotte together with Duke Energy, and it's running now in commercial operation. So here you see a nice picture of this huge machine. And this is additional a picture how the capability to co-fire hydrogen, which is also necessary for decarbonization. And here you can see the CO2 reduction. The 9000 HL can 50% up to now, and we have also an AGT which can fire 100% hydrogen. And the goal, of course, is the mission is to burn 100% hydrogen in all machines at 2030. If you ever see this logo, it's called H2 Ready. It's a certification for our customers. So all these machines are lubricated with, most of the machines are lubricated with mineral turbine oil. We have a turbine oil specification called TLV 191305. This specification for turbine oils with higher thermal stability was developed together with the DIN 51515 Part 2 in 2010, when I was chairman of the DIN committee for turbine oils. At that time, I tried to align the TLV with international specifications like the DIN, the ASTM D4304, and the ISO 8068. And this has been done quite well, but there are differences in some requirements due to differences in these standards. And whoever worked in standardization knows how hard it is to bring everything together in one specification without any deviations and to find compromises. Here's the table of our specification. This is the version of 2020, the newest version. Of course, the viscosity is defined. We have two viscosity classes defined, 32 and 46. Viscosity index, air release, which is a very important parameter for us for the operation. Here's also a difference. We have defined 4 minutes maximum for the new oil, and in the other specifications, they have 5 minutes, but the difference can also be important. We defined the maximum neutralization number. We defined also contamination, maximum of 200 ppm water. Foam is relatively relaxed value compared to other standards with 450 milliliters. And we have two parameters defining the water separability. One is the steam method developed in Germany with 300 seconds, and the demulsibility known from the ASTM D1401 with 30 minutes for the separation of water and oil. Then we have defined, of course, the flash point, the pour point, the cleanliness level. When the oil is delivered, we have 2 corrosion tests, which are common, and the special or the difference to the old specification for normal thermal stability is the RPVOT test, which we put in this specification, like in the DIN Part 2, with 750 minutes, which is also in the most specifications the same requirement. Then we have also additional the TOAST test with 3,500 hours. For gearbox applications, we have also a failure load stage of 8 or more than 8 in the FZG test, which is required mainly by our industrial steam turbines, which run at higher frequencies and use a gearbox at higher RPMs. Yeah. We have additional written requirements as followed. In particular, it defines the type of oil, the additives that can be used, and the operating temperature that the oil must be able to withstand. The 130 degrees maximum temperature was agreed with the oil industry when I was writing this standard, and I think it's still valid. Maximum temperature in bearings and so on, and 80 degrees centigrade in the oil tank as a permanent temperature. We have an approval list, we have an approval procedure. This procedure is also described in the TLV, and I have been leading this process for the last 29 years now. As a result, there have been more than 250 approved turbine oils, all tested and approved by our laboratory according to our specification. I would say this list contains the who is who of turbine oils. So now we have the specification and the oil, and now we fill it in the machine and have to monitor it. And when we get a sample in the laboratory, we assume that the sampling was done correctly and that we have a representative sample, very important. If there's any evidence that this is not the case, the analysis and the recommendations can be dropped. Normally we run the following program in our laboratory, which is specifically tailored to turbine lubricating oil. This is in particular viscosity. And we have also warning limits defined. Of course, the plus minus 10% come from the definition of the viscosity classes. If there is a delta or a difference to the last analysis of more than 5%, you must be careful. Then maybe a wrong oil has been added to the filling. Normally it doesn't change so much. The air release, the maximum value is 8 minutes, but they also can occur problems before, especially when the temperature is lower than 50 degrees centigrade, where the air release is measured, and which is the normal temperature about that in that region in the tank. But if the tank is still cool during startup, it can be that the tank temperature is lower than 40 degrees centigrade. And if you go down 15 Kelvin to 35, the value nearly doubles. And this means if you are at 8, it may be 16 at the startup, and then you can get trouble with pump pressure drops and so on, and failure during start. Very, very important parameter, depending also on the circulation number and the design of the machine. Total asset number should be lower than 0.3 in a new oil. If there is an increase of to the last analysis of more than 0.1, then you should also be careful and look for the reason for that. The water content, the maximum value, the warning limit is 300 ppm. If you get higher values of water, you can look for the source where it comes from, and you must be careful because from about 400 ppm, depending on the temperature, you get free water in your oil sample, and this is not good for the lubrication process. Then you also can get issues with lubrication. Foaming characteristic, we accept the high value of 450, but if it's going higher, there should be taking action, because otherwise you can get problems, for example, with the level measurement in the tank. And you may have contamination somewhere. Water separability and demulsibility can be a problem if these both values are, if the values are higher than 600 seconds or 30 minutes in the steering method. Then there is no separation often if water gets into the tank, however, and If there's no separation, unfortunately, you cannot drain the oil at the bottom of the tank, and this can be a problem then you don't get rid of the water. If you then have to operate your turbine and you cannot stop, and even if you stop, it takes a long time that it separates. And the cleanliness level, of course, contamination is always an issue. If it's too high, you can get problems with scratches and so on, but you also can have an indication of varnish. I will show you afterwards. Ruler, the antioxidant content is one of the main parameters. You have heard it in other presentations. If it's lower than 50%, you should take actions. If it's going lower than 25%, maybe it's not possible to replenish any the antioxidants, because you then got maybe base oil oxidation and also an increase of the total acid number. And last but not least, the MPC value, which is also really necessary to measure in the modern turbine oils, which shows the varnish potential. And if it's going over the normal value of 15, you should be careful and monitor it. If it's going to 30 or 40, can get critical, and then you must be sure. Or then of MPC values of 40 indicate that normally you have varnish in the system, and you can find it and see it. This is recommended every 6 months, this analysis program. So one example, here we have an analysis of a industrial steam turbine, everything okay, but we have a high cleanliness code. In this case, we always heat the sample up in the laboratory, let it cool down again, and directly measure it. In this case, we have done that, and we see a significant drop, especially the particles of more than 6 microns from 22 to 17. That means they are heat soluble, and this is a good indication that we have varnish in the system. And additional, with this high value of 39, it's a good indication that you have to take action against this varnish. Look at the antioxidant content. You have this amine and phenol antioxidants in your oil. And if you measure it with a ruler, you get a good impression about the rest oxidation stability of the oil. In this case, we have more than 90% of the amine type antioxidants. And this shows still a good oxidation stability. Yes, and what to do with these values? If you have this improvement, if you have these values and you have deviations, you must do improvement measures. And I put together three examples, which we find relatively often in our lab. If you have a strongly based base oil, e.g. a high ton, or if you have poor air release or demulsibility, which is mostly irreversible damage to the oil, and you have a high MPC value and varnish and deposits in the system, then it's only possible to clean the system up, maybe with the old oil, and then change the oil. But if you have only a high MPC value and varnish in the system and particle count high, decreasing in heated oil, as I showed you, but you have sufficient antioxidant content in your oil, then it is possible to clean up the oil and continue operation with the same oil. It's not necessarily has to be changed in this example. Same example with low antioxidant content shows that that you have to add something to the oil. You have to clean the oil up. If you have to treat the oil, you have to re-additize the oil, and then you can also, with this filling, continue operation. How can this be done? In the first case, you need a system cleaner and new oil. Maybe, for example, the Fluidtech products Decon and Infinity, which we made which we use a lot for cleaning up. If you have to clean and continue, you can use the ESP method, ion exchange resin cleaning, to take out the varnish from the oil. And if you have to clean, treat, and re-additize, then you can use a resin cleaning, a solvency enhancer, and also antioxidant addition. And in this case, you can go for a fill for life with this filling, if the other parameters are all okay. Adding antioxidant, we have here a nice case study where we did it in an oil which was filled in 2010. You see the blue line is the reference from 2010. And it dropped in 2019 to 25%, the brown line. And then we decided to re-additize it and put a soluble enhancer in. And we have here a nice addition of antioxidants can be seen, 2020. And additionally, we have seen that the MPC number goes from 55 down to 5. So we have two results: good oxidation stability again with this oil, and an improved resistance against varnish due to the solubility enhancer. So let me summarize my presentation. Siemens Energy has a turbine oil specified by TLV 191305. We have an approval list where you can find all the approved turbine oils. We have a monitoring program defined. This includes also the important parameters, varnish potential and antioxidant content, which we recommend to all of our customers. And in case of deviations in the parameters of the monitoring program, we have countermeasures which are defined and also approved, like system cleaning, resin cleaning, antioxidant addition. We used a lot of times in the last, let me say, 10 years. By combining this solvency enhancer, the resin cleaning and antioxidants top up, the service life of the oil can be extended to fill for life. And this then is really a sustainable maintenance management and can save a lot of oil and so save our earth. Thank you for your attention, and now I'm ready for questions.
Thank you, Ludger. Yeah, it's very lots of new things. It's very mind-opening to think the new possibilities that exist now. Among the questions, we have one from your colleague in oil analysis, Koen Balman from NG in Belgium, asking a specialized question, which is which actions can be performed when foaming tendency is too high, when you see too high foam?
Sometimes foaming tendency is due to fine particles. So it's also sometimes possible to make a fine filtration to remove the particles. And sometimes we have also seen an improvement when we made the ESP cleaning, other the resin cleaning.
Okay, thank you. We also have a question from Bruno. And the question is, what role can acidity play on lube oils in the aero-derivative turbines?
In the aero-derivative turbines, we have normally another oil, not a mineral oil, but a polyol ester, as I know, and we have not so much experience with it in our laboratory, but it is also possible, I think, to remove these by filtration. These are acids, and maybe it's possible. I have no proof that it works with the ESP, but maybe it's worth a try.
I have a question here for Ahmed. I think maybe a bit surprising question, but very, very important. So Ahmed Mazhar is saying, main issue is always varnish. And he put caps lock, varnish in capital letters. Why can't Siemens have a bulletin device filtration system that is taking care of this matter?
We recommend strongly the ESP method to remove varnish, and we have also service information for that.
Yeah. So
if he wants to know more about the service information, he can send me an email, and I can give him the service letter we made for our customers. Of course, it cannot be distributed to everyone, but if the people come to us and ask us, we have good solutions for that.
Yeah, so Ahmed, it's such a good question that there is actually such a bulletin. So we can only recommend to contact Dr. Quick by yourself, okay?
Yes.
We have a question also from Nicolas Cominos. What recommendations do you have regarding the sampling point and procedures for sampling?
Yeah, a sampling procedure is really necessary to have a good sampling point in the system, which is normally located in the area of the filters. Before or after filter, you can take a sample during operation. This is the most important. We have heard it this morning. Don't take a sample when the unit is not in operation. You can only get wrong results. And the sampling point, as I said, at the filters, there is a good point, and not from the bottom of the tank. There you get all this stuff which gets to the bottom of the tank, like water and contamination, and you get not a representative sample then. And you have to flush. You have to flush the vent where you take the samples properly. Otherwise, you get the particles from this valve into your bottle.
Yeah, thank you. Yeah, sampling is a key aspect of all of this. There are resources from such magazines as Machinery Lubrication and Precision Lubrication regarding sampling, and I encourage everyone to study the matter.
Yeah, that's great.
Now, I have a question myself regarding what you see as proper oil condition monitoring for your machines. From the feedback you get from your users, customers, what do you think is the percentage today of the users, customers who have the right practices for oil condition monitoring in service as of today? What is your feeling?
Depends. If they have a good monitoring program in place, they all know about the parameters and they follow the recommendations. But often it is so that they don't measure, for example, antioxidant content, MPC measurement. They only analyze the cheap values like viscosity, water content, and maybe metals, and they don't get the information which you need to take the correct actions. So this is a problem. If the customers know the monitoring program or read it, then it's no problem. But it's also a question of availability of good laboratories worldwide, I think.
Okay, thank you. We have another question which is also very key. And the question is, I might have misheard. Did you say that ruler is below 25%, then you can't clean and treat the oil?
This is what I learned where the 25% come from, that then you must assume that aging of the base oil starts. And of course, it depends then on the complete analysis and an evaluation. But I would recommend to think about measures before it's so low. And as you see in my example, it works. It has worked at 25%, but if it's even go lower than 25%, I would be careful. Yes. And evaluate the base oil aging.
Thank you. I think we can say that ruler, it's important to trend it. So do it early and do it periodically so that you see a trend. And then you can predict in advance when you will hit this floor level.
Yeah.
Okay. Well, we've just hit the end. So, Ludger, I can't thank you enough. Great presentation, and see you later again. Thank you.
Thank you, Guillaume, for your help. Thank you.
Thank you. Bye-bye.